The XKC series controls have the ability to turn fans on as well as shut off fans by monitoring temperature values underneath the hood and comparing them to 4 set points. These 4 set points are room temperature, temperature interlock offset, temperature interlock hysteresis, and hysteresis timer. By constantly monitoring the temperature underneath the hood with temp sensors, the controls will know when to lock the fans on and when to automatically turn the fans off. First, let's look at an example graphic to help demonstrate how these 4 set points work in real time. Here, we see a hood with a temp sensor over a set of cooking equipment. With nothing on underneath the hood, the fans are free to be turned on and off via the fan button on the touchscreen. Once the cooking equipment is turned on underneath the hood, the temp sensor values begin to rise due to the hot air underneath the hood. At all times, the temp sensor values are being compared to the room temperature. In this example, there is no room temp sensor, so we're going off a preset room temperature. If there was a room sensor, this value would change depending on the value the room sensor is reading. Again, the fans are still free to be turned on and off manually by the touchscreen until the temperature reaches the temperature interlock offset. The temperature interlock offset is the difference above the room temperature in which the fans will be locked on. At this point, if fans were not already on manually, they will be turned on automatically. Once temperature interlock is met, fans can no longer be turned off via the touchscreen. You will get a message saying fans cannot be turned off. Temperature sensors are detecting cooking temperatures. This will continue to be the case until temperatures underneath the hood cool down enough for the fans to begin to shut off automatically. How much the temperature must fall below the temp interlock set point is determined by the temp interlock hysteresis value. Temp interlock hysteresis can simply be thought of as a difference. Once temperatures go below this temp interlock hysteresis, a timer will start to shut the fans off automatically. If at any point the temperature goes above the temp interlock hysteresis during the timer, fans will continue to be locked on and the timer will reset. Once the temperatures are below the temp interlock hysteresis, for the entire duration of the timer, fans automatically shut off and will show off on the touchscreen. Once fans shut off, they can always be turned back on via the touchscreen fan button. Now that we've seen how that works with the 4 temp set points, let's go over the scenario again showing actual values for the set points. The set point values we will be using are as follows: a preset room temperature of 75 degrees, a temperature interlock offset of 20 degrees, a temperature interlock hysteresis of 10 degrees, and a hysteresis timer set for 10 minutes. Again, we have our example cooking setup. As equipment is turned on, temperatures begin to rise. As the temp continues to rise, they pass 95 degrees, so the fans enter temperature interlock. The fans are turned on automatically if not already on manually, and are at this point locked on and cannot be turned off by the touchscreen. As cooking equipment is turned off, temperature begins to fall. Once the temperature falls past 95 degrees and gets down to 85 degrees, the hysteresis timer starts. For fans to shut off, the temperature must stay below 85 degrees for the entire 10-minute timer. After temperature is below 85 degrees, for 10 minutes, the fans will automatically shut off. Now that we see how operation works, we can look at 2 different common issues that have to do with the 4 settings and how we can solve these issues by simply adjusting the set points. The first common issue is the fans are stuck on and are not able to be shut off by the touchscreen. If the touchscreen has a temp sensor fault, this issue is caused by an error in the sensor or wiring to the sensor. Please see the temp sensor portion of the video for that. Let's go over an example in addressing the fans being stuck on. In this example, we have excessive heat coming to the temp sensors even with the equipment off. Typically, this can be caused by pilot lights on gas appliances or simply high ambient temperatures underneath the hood. To see temperature sensor values, we can navigate to the temp sensor menu of the controls diagnostics. By navigating to the menu and hitting enter on the main board, we can see the extra heat is causing the temp sensor to have an elevated value of 87 degrees. It is important to look at the temp sensor with the highest value if there are multiple sensors. Now that we know the highest temp sensor values, we can navigate to the zone settings menu to look at what our set points are set at. Choosing Zone 1, we first enter on Preset Room Temperature to see it is set at 75 degrees. Hitting Escape, we can then go to Temp Interlock Offset. We see that it is set at 20 degrees, making our lock-on temperature 95 degrees. Going out, we check our temperature interlock hysteresis, seeing it is set at 10 degrees. So we know that 85 degrees is our off set point. Going back out, we go to check our hysteresis timer, and we see it's set for 10 minutes. Since our elevated temperature is keeping the temperature sensor at 87 degrees, 2 degrees above our hysteresis temperature, or fan off temperature, we need to be able to set the locked zone, or the fan off temperature, to be above what the lowest temperature our setup will allow. When making any adjustments, try to stay within a 5-degree difference from the original values, making only incremental changes. Going into temperature interlock offset, we will change this from 20 to 22 degrees, making our lock-on temperature 97 degrees. This will move our fan off temperature up, but we will still go into the hysteresis settings and adjust that down to 8. This will make our off temperature 89 degrees. We will leave the timer for 10 minutes. Now, after the temperature sensors reach 97 degrees and are locked on, the temperature will only need to fall to 89 degrees for 10 minutes. If the temp sensor is at 87 degrees, this should be able to be met with all equipment off. Since the fans were locked on, it's best to cycle power to the controls after changing temperature settings. This will reset the temperature logic and give the kitchen control of the fans again. Now, the second common issue is when fans shut off prematurely or during the middle of cooking. Let's cover an example of the cooking temperature causing fans to shut off during cooking. Looking back at our test kitchen, maybe during parts of the day, hood temperatures fall due to a decrease in cooking load. Going back into diagnostics, we can see that the highest temperature sensor value during this lull is fluctuating between 82 and 84 degrees. Knowing this, we will again go into zone settings and check out our set points. Note that they are the same as the previous example. As we can see, during the lull in cooking, the fluctuation of the highest temperature sensor being between 82 and 84 would put us below the fan off temperature of 85. And if this should stay like this for an entire 10 minutes, the fans would automatically shut off, requiring them to be turned back on from the touchscreen manually, or for the temperature to rise above 95 for the fans to turn on automatically again. To resolve this, the goal would be to get the fans to shut off automatically only after all equipment is properly shut off. To accomplish this, we would want the temperature off set point, or the temperature interlock hysteresis, to be below temperatures we were seeing when half of the cooking equipment is off. Like in the last example, we'll want to only make incremental set point changes within 5 degrees of the prior values. First, we'll go into temperature interlock offset and turn this down to 15 degrees, making our fan lock-on point be 90 degrees. Since our hysteresis is still set at 10, this would put our fan off set point at 80 degrees for 10 minutes. This adjustment should be enough to keep their fans on until they have finished cooking or all equipment is off. In both of these examples, we used a preset room temperature set point. If your controls came with a room sensor, the room temperature set point will fluctuate with the reading on the room temperature sensor. All temperature sensor values can be checked in the diagnostics menu of the controls. In both examples, we were able to go into diagnostics and check temperatures during the points in which our problem was being experienced. This is always the recommended method, as you will be able to perfectly set the temperature settings according to your situation. Here are a couple general recommendations on quick fixes for fans being stuck on due to temperature, or from fans going off too early due to temperature lulls. As a reminder, we want to keep temperature set point adjustments between 1 and 5 degrees. For fans being stuck on, we can always slightly increase the temperature interlock offset set points and/or decrease the temperature interlock hysteresis. For fans shutting off before cooking is done, it's best practice to turn fans on manually rather than rely solely on the temperature interlock. Otherwise, we can decrease our temperature interlock offset and/or increase our temperature interlock hysteresis.